Hello all, welcome again to the paper discussion of mathematics part test 13. So let's begin. 51 here is if alpha comma a are roots of the equation x square minus 2x plus 3 equal to 0, then the value of alpha cube plus a cube minus 3 alpha square minus a square plus 5 alpha plus a divided by alpha square a plus alpha a square is. So if you observe, alpha and a are the roots of the given quadratic, so I can write the product of root as minus b by a, which will become 2, and the product of roots alpha into a, that is c by a, that will become 3 here. Now we need to rearrange the things here so that we can get these answers. So if you observe, in the numerator we have alpha cube plus a cube. So let's find out that part first. I can write this as alpha plus a whole cube minus 3 times of alpha into a, alpha plus a. Okay, so I have the alpha plus a value, so this will be 2 cube minus 3 into product of roots alpha into a, that is also 3, and this is 2, so basically it is 8 minus 18, so this value is coming out to be minus 10. So we have found out the first part. Now if you observe, minus 3 alpha square minus a square is written, so out of that, let us try to arrange the things. So I have alpha cube plus a cube value already, so that I will write as minus 10, and then minus, we have 3 alpha square, but I will take only alpha square for the moment and take minus also common, so it will become alpha square plus a square, and the remaining minus 2 alpha square I will write it afterwards. So minus 2 alpha square plus 4 alpha plus a, 5 alpha we have written as 4 alpha plus alpha, so that at last also I can apply the sum of roots formula. Now since we require alpha square plus a square, that also I can calculate by using alpha plus a whole square minus 2 alpha into a, which is going to be 2 square minus 2 into product of root, which is 4 minus 6, that is minus 2. Now let's substitute all these values here. In the denominator you can take alpha a common, so it will be again alpha plus a. Now if you observe the values, this is minus 10 minus of minus 2, and again I can observe that here it is minus 2 alpha square plus 4 alpha. If you see this equation, alpha is a root of this, so I can say alpha square minus 2 alpha plus 3 will be equal to 0, and if I want, I can also multiply with 2, so it will be 2 alpha square minus 4 alpha plus 6 equal to 0, and from there I can also say that minus 2 alpha square plus 4 alpha value is basically 6. So in the place of this minus 2 alpha square plus 4 alpha, I can simply write plus 6, and again in the place of alpha plus a I can write plus 2. So this overall thing, if you observe in the denominator, that is also 3 into 2. Now minus 10 plus 2 plus 6 plus 2, numerator is becoming 0. So the answer is going to be 0 for this particular question, which was option number B. Question number 52 is if alpha, beta, gamma are the roots of the equation x cube plus 2x minus 5 is equal to 0, and if the equation x cube plus bx square plus cx plus d equal to 0 has roots 2 alpha plus 1, 2 beta plus 1, 2 gamma plus 1, then the value of modulus of b plus c plus d is. So if you observe this cubic equation, it has roots as 2 alpha plus 1, 2 beta plus 1, 2 gamma plus 1. So I can say x is equal to 2 alpha plus 1 as one of the roots. From there I can say alpha is nothing but x minus 1 by 2. Now coming to this cubic equation, it is given that alpha, beta, gamma are roots of this. So definitely alpha must satisfy it. So I can say alpha cube plus 2 alpha minus 5 must be equal to 0. Now putting the value of alpha here, I can say it is x minus 1 by 2 whole cube plus 2 times of x minus 1 by 2 minus 5 is equal to 0. Now 2 and 2 is getting cancelled, and here we have x minus 1 whole cube. If you observe x minus 1 cube, it will be x cube minus 3x square plus 3x minus 1 divided by 8, and here we have x minus 1 minus 5 equal to 0. So let us take the LCM. It will be x cube minus 3x square plus 3x minus 1 plus 8x minus 8 minus 5 into 8. It should be 40 here at the end, that is equal to 0. So overall we are having x cube minus 3x square plus 11x and then minus 49 is equal to 0. This is the cubic equation we are getting. And if you see, alpha, beta, gamma were the roots of one of the cubic equation from where we have derived this cubic equation. So comparing with the x cube plus bx square plus cx plus d equal to 0 equation, x cube plus bx square plus cx plus d equal to 0, we can say that b value is minus 3, c value is 11 and d value is minus 49. So the mod of b plus c plus d will be minus 3 plus 11 and plus minus 49. That will give us 41, which is option number A. Question number 53 is, if ax square plus bx plus 6 is equal to 0 does not have two distinct real roots, then the least value of 3a plus b is. So this is a quadratic and it is said that it is not having two distinct real roots, which means single root is possible, but otherwise two different roots are and real roots are not possible. So first of all, we have to put the discriminant condition that discriminant can be equal to 0, but it cannot be positive. Otherwise, that will give us the condition for two distinct real roots. So it can be negative or it can be equal to 0. So even if we apply this discriminant condition, it will be b square minus 4ac. So we have a into 6 here and less than or equal to 0. So I can only say that b square is going to be less than 24a. But we don't have any information on a and b. So what can be the other way of understanding this question? So this is the x-axis and the graph of this function, if you just take ax square plus bx plus 6 and if you put in that particular function fx is equal to ax square plus bx plus 6, if you put x is equal to 0, you can observe that you will be getting f0 is equal to 6, which means we are getting a positive answer. So function is basically above x-axis. So it suggests that at 0, if this is the value 0 on x-axis, then we are having 0,6 over here. And now suppose the graph is coming down, since it is a quadratic, it can be a curve upward parabola or it can be a downward parabola. Now it can maximum go and touch the x-axis and again go up, okay? Or the other possibility is that it may not touch x-axis at all since d is less than 0. That is also possible. So like this also it can go. Therefore I can clearly say that it is going to be positive for all the other values of x also, because for any value of x, if this graph is going and cutting x-axis like this, then to again rise upward it needs to cut at the other value also, some other value, some distinct value. Therefore that is not possible, and we can conclude that the graph is always going to be above x-axis or it will just touch the x-axis and move upward. So only these possibilities are there, okay? So I can conclude that function fx is going to be greater than or equal to 0 for all x values belonging to R. So therefore definitely same thing will happen for f3 also. F3 should be greater than or equal to 0. And how I'm able to say that I have to apply f3 only, because they are asking the least value of 3a plus b. So somehow I need to create 3 times of a. So for that I am putting 3 in the equation so that I get 9 times of a plus 3b plus 6. Okay, this is going to be greater than or equal to 0, and if I take 3 as common, it will be 3a plus b and greater than or equal to minus 6, which means I can say 3a plus b is going to be greater than or equal to minus 2. So the minimum value is minus 2, which is option B. Question number 54 is, let alpha, beta, gamma be the real roots of the equation x cube plus ax square plus bx plus c equal to 0. And if the system of equations in u, v, w given by alpha u plus beta v plus gamma w equal to 0 and so on has non-trivial solutions, then the value of a square by b is. So these are the three equations given in u, v and w. So the coefficients of u, v, w basically forms the coefficient matrix basically, which is represented by A usually. And for non-trivial solutions, we know that for homogeneous system of equation, this is a homogeneous system of equation because we have 0 0 0 on the right hand side. So definitely it is AX is equal to 0 matrix format, where A is the coefficient matrix formed by the coefficients of U, V, W. So the determinant of that has to be 0 for non-trivial solution. That is the condition. So we have alpha, beta, gamma over here. Next will be beta, gamma, alpha, and then gamma, alpha, beta. And this determinant value I need to put it equal to 0. Now I can apply an operation, elementary operation in first row, which is R1 plus R2 plus R3 to simplify this determinant. So it will be alpha plus beta plus gamma. Again we have alpha plus beta plus gamma, and again we have alpha plus beta plus gamma. Okay, so this is beta, gamma, gamma, alpha, this is alpha, beta. Alright, this is equal to 0. I can take alpha plus beta plus gamma outside, common from the first row. So we'll be left with 1 1 1, and then beta, gamma, alpha, and gamma, alpha, beta, that is equal to 0. So this becomes alpha plus beta plus gamma, and now simply I can expand this entire thing. So it will be beta gamma minus alpha square, then minus 1 we can have beta square minus alpha gamma, and then plus 1 I can have alpha beta minus gamma square. So overall I am left with alpha plus beta plus gamma. Alright, and then inside the bracket, if you observe, we have minus alpha square, we have minus beta square, and we have minus gamma square as well. So minus can be taken common, and it will be minus of alpha square plus beta square plus gamma square. And then we have alpha beta, beta gamma, and gamma alpha as well. Okay, so the entire thing is completed. Now basically this determinant needs to be equal to 0, and now we need to think about the values that we are having, like alpha plus beta plus gamma. This is nothing but sum of roots, and sum of roots can be found for this cubic equation as minus a by 1. Okay, and then we have another minus sign here. What is this alpha square plus beta square plus gamma square? This is nothing but, separately we can find it out. Let's suppose we have alpha plus beta plus gamma whole square. That will give us alpha square plus beta square plus gamma square, and then 2 times of alpha beta plus beta gamma plus gamma alpha. Now this alpha beta plus beta gamma plus gamma alpha, this value is basically b from the cubic equation again. Okay, we have the sum of the product of two roots at a time, that is simply b by 1. So I can say this value is basically a square, that is equal to alpha square plus beta square plus gamma square, and this will become plus 2b. So whatever is required, that is basically a square minus 2b. And then just now I told you that alpha beta beta gamma gamma alpha, that is nothing but we have b. So this thing must be equal to 0. So now we have the values. If you observe, a comma b should not be equal to 0, so this outside term cannot be equal to 0, which basically means I have to make this second bracket equal to 0. So this is minus a square and minus minus plus 3b. Overall I will be getting plus 3b equal to 0. So a square is equal to 3b, so we have a square by b as 3, which is option B. We have question number 55. If mod of z1 is equal to 2 and mod of z2 is equal to 3 and mod of z3 is equal to 4, and as well as we have been given with mod of z1 plus z2 plus z3 is 5, then the modulus value of 4 times z2 z3 plus 9 times of z3 z1 plus 16 times of z1 z2 is equal to. So you know that z into z bar is equal to modulus of z square. Okay, so if you see these numbers carefully, 4 9 and 16, they are nothing but square of these provided modulus values 2 3 and 4, correct? So definitely it gives us a hint. So in place of this 4, I can write it is nothing but mod of z1 square, which is nothing but z1 into z1 bar also. Same way I can make the changes for 9 also. I can write it as mod of z2 square, which is basically z2 into z2 bar, and 16 as z3 modulus of z3 square, which is z3 into z3 bar. If you put all these values, you will observe that this is nothing but z1 z1 bar, z2 z3 plus z2 z2 bar, z3 z1 plus z3 z3 bar, z1 z2. Overall, if you observe, in each of these terms I can take z1 z2 z3 common. Okay, z1 z2 z3 common, and we'll be left with z1 bar plus z2 bar plus z3 bar. Now this z1 z2 z3, they can be taken outside of this modulus separately, and we can take their mod values separate, and the remaining thing I can write z1 plus z2 plus z3, and conjugate is there on each of them, so as a whole I can put a conjugate sign. But we also know that mod of z is equal to mod of z conjugate as well, so it doesn't make any difference. We have all the available values like 2, 3, 4, and this entire value will also be 5, because z1 plus z2 plus z3 mod was 5, so its conjugate will also have same value. So if you multiply all this, it will be 6 into 20, which is 120. Option D is correct. Question number 56 is, if z and omega are two complex numbers such that modulus of z into omega is equal to 1, and argument of z minus argument of omega is equal to 3 pi by 2, then argument of 1 minus 2 z conjugate into omega divided by 1 plus 3 z conjugate into omega is. Let's say argument of z is some theta value, and z is represented by some r e power I theta, okay, in this format. uh, then we can say that argument of omega from this particular equation is nothing but argument of z minus 3 pi by 2, or basically I can say it is nothing but theta minus 3 pi by 2. Okay, this is the argument of omega. Now also we are given with modulus of z into omega is 1, so I can say modulus of omega is nothing but 1 by mod of z, or modulus of z. So this is already we are knowing that modulus of z is basically r. Okay, we have taken that in that format itself, so it is going to be 1 by r. So how to express omega now? It is going to be 1 by r, then e power I into, in place of theta we have the argument of omega as theta minus 3 pi by 2. So we are having both z as well as omega ready. So if you see the given complex number 1 minus 2 z bar omega by 1 plus 3 z bar omega, let's try to calculate this. It is 1 minus 2. The meaning of z bar will be that it will become e power minus I theta, so it will be r e power minus I theta, and omega value we have 1 by r e power I theta. This I am writing separate so that it will become minus 3 pi by 2i. Okay, after multiplying we can separate these terms, and denominator also let's express. This is 1 plus 3 r e power minus I theta into 1 by r. Again same to same, we have to just copy paste everything. Okay, now let's see the values. R and R will get cancelled over here. Okay, e power I theta and e power minus I theta, so these terms will also be getting cancelled. Same way in the denominator also, R cancelled, these terms will get cancelled, and we are left with uh, e power I theta is basically written as cos theta plus I sin theta. Okay, cos theta plus I sin theta by Euler's form. So if I am putting in place of theta minus 3 pi by 2, cos term will be 0, and sin minus 3 pi by 2 is basically minus of sin 3 pi by 2, which is again going to be 1 only. So it is going to be just I at this particular angle. If I calculate, it is going to be I. Okay, so we are left with 1 minus 2i and divided by 1 plus 3i. Okay, because this term is same, so we need to basically find out the argument of this complex number. So to find that, we have to rationalize this. So again 1 minus 3i I will multiply and divide also. So overall in the numerator I will be left with 1 minus 5i, okay, and minus minus plus 6i square, which is basically minus 6, and denominator will be 1 minus 9i square, which is again 1 plus 9 10, right? So we are left with minus 5 minus 5i, minus 5 can be taken common, 1 plus I divided by 10. So our complex number is basically minus half 1 plus I. Okay, so we need to find out the argument of this complex number, that the real part is also minus half, which is negative, and imaginary part is also minus half. Okay, so it is something like this. The point is somewhere here. So this angle is going to be 45 degree. Okay, because x and y both are half. So this will be also half, and this perpendicular, that is also half. So this angle is 45 degree. And for principal argument, the okay, for any principal argument of complex number, it should always be from minus pi to pi. Okay, so here our answer has to be from this direction. Okay, I cannot measure it from the positive x-axis in anti-clockwise direction, otherwise it will cross pi. So clockwise it was 45 degrees, so I can say it is nothing but 135 degree, but in clockwise sense, and therefore I should report the answer to be argument of z equal to minus 135 degree, or basically minus 3 pi by 4, which is option B. Question number 57 is, if alpha and beta are the roots of equation k plus 1 tan square x minus root 2 lambda tan x plus k minus 1 equal to 0, and tan square alpha plus beta is 50, find lambda. And alpha and beta are the roots. If you see, this is a quadratic in tan x. Okay, so when I put alpha and beta in place of x value, it will be basically tan alpha tan beta, effectively the roots. So I can say the sum of roots tan alpha plus tan beta, that will be given as minus b by a. For this, that will be root 2 lambda by k plus 1. Similarly, the product of roots will be tan alpha tan beta, which will be k minus 1 by k plus 1, as per the c by a formula. So now I can apply the tan alpha plus beta formula, which is basically tan alpha plus tan beta divided by 1 plus tan alpha tan beta. Okay, so it is tan alpha plus tan beta divided by minus tan alpha tan beta. Let's put the values. It is going to be root 2 lambda by k plus 1 divided by 1 minus k minus 1 by k plus 1. After taking LCM, it will be root 2 lambda by k plus 1 minus k minus 1. Remaining things will get cancelled out, and this is going to be root 2 lambda by k minus k will get cancelled. I will be left with 2 in the denominator. So effectively lambda by root 2 is what we are getting. But in the question they gave that tan square of alpha plus beta is 50. So it means lambda square by 2 is 50, and therefore lambda square is 100. So the value of lambda is, question number 58 says, which of the following matrices cannot be obtained from the matrix given by a single elementary row operation? So if you see the first option, I can very easily apply in the given matrix R1, R1 plus R2. In R1 I am applying R1 plus R2, and I can get this A matrix easily. Same way in B matrix, if you observe in option B, we are having 1 and minus 1 in the numerator. So I can basically apply R1 interchanging with R2, and easily I can obtain within a single in a single elementary row operation. If we apply R2 plus 2R1, then in a single row operation you can get D also. Option number C, it is not possible. So that will be the right answer. Question number 59 is, let Z1 is equal to 2 plus 3i and Z2 is equal to 3 plus 4i. The set S consisting of complex numbers Z such that Z minus Z1 modulus square minus Z minus Z2 modulus square is equal to square of the modulus of Z1 minus Z2. So as you can see, Z1 is 2 plus 3i, and let's suppose Z is x plus iy. Then this first term Z minus Z1 modulus, and then we have a square over that modulus. That will be nothing but x minus 2 whole square plus y minus 3 whole square. Okay, and then next term will be minus z minus z2. z2 is 3 plus 4i, so this will be x minus 3 whole square plus y minus 4 whole square, and that is equal to z1 minus z2. So z1 minus z2 means 3 minus 2 whole square plus 4 minus 3 whole square. So let us expand this. If you see, we will get x square minus 4x plus 4. Then we will get y square minus 6y plus 9. And after expanding this, I'm sending this minus inside. So it will be minus x square plus 6x minus 9 minus y square plus 8y, and then minus 16 is equal to 3 minus 2 is 1. 4 minus 3 is also 1, so this is going to be 2. Now you can see the cancellations. X square minus x square, y square minus y square cancelled. So we are left with 6x minus 4x, 2x, then 8y minus 6y, that is 2y, and remaining 4 and 9, 13. 13 minus 9 again 4. 4 minus 16 is minus 12, which will go to right side, and it will be overall 14. So it means it is nothing but x plus y is equal to 7, which is a straight line with intercept 7. Okay, so straight line with the sum of its intercepts on the coordinate axis equals 14. That will be the correct answer, because a is equal to b is equal to 7 if I write this in terms of intercept form. So the sum of these intercepts, definitely it is 14. Option D is correct. Question number 60 is e power 4x plus 8 times e power 3x plus 13 into e power 2x minus 8 e power x plus 1 is equal to 0 for x belonging to R has four options, four solutions, two of which are negative, then two solutions and both are negative, and so on. So to solve this question, let us divide throughout by e power 2x. Okay, so this will be e power 2x plus 8 e power x plus 13 minus 8 by e power x, and then plus divided by e power 2x, that is equal to 0. Now let us club the similar terms together. We have e power 2x plus 1 by e power 2x together, and if I take 8 common, it will be e power x minus 1 by e power x, and then plus 13 is equal to 0. So let's write this first bracket as e power x plus 1 by e power x whole square. So when I open this bracket, I will get these two terms, but apart from that I will get plus 2 also extra. So for that I am subtracting minus 2. For that I will put minus 2 here, and then we have plus 8 times. Also we can see we have 8 times e power x minus 1 by e power x. So we can also do a slightly better modification here, that we can write e power x minus 1 by e power x whole square. Still I will get these two terms. Okay, and this time I have to do plus 2 here, and now it will be much more better. So e power x minus 1 by e power x plus 13 is equal to 0. Now in place of this e power x minus 1 by x, you can use some capital Y term. So y square plus 8y, and 2 plus 13 will give us 15, that is equal to 0. Now this is easily factorizable. 5 and 3 together will give 8, and 5 into 3 will give 15. So I can write this as y square plus 5y plus 3y, and further after factorization I can write this as y plus 3 y plus 5, that is equal to 0. So basically we have got two answers, y is equal to minus 3 and y is equal to minus 5. So from here, what was the y value? It was e power x minus 1 by e power x, that is minus 3. Similarly, this side I can say it is e power x minus 1 by e power x equal to minus 5. So this is nothing but e power x whole square plus 3 e power x, okay, minus 1 is equal to 0, and this side we can get e power x whole square plus 5 e power x minus 1 is equal to 0. Two quadratic equations we have got. So if we solve this quadratic equation, so using the left side quadratic in exponential, we will get e power x value as minus 3 plus minus root over b square minus 4ac, which will be 9 minus minus plus 4 divided by 2. Now if we observe, exponential functions can never be negative. So I cannot take minus 3 minus. So only one solution will be acceptable here. Only one solution this side. Same way, if we solve this, the other case, e power x is equal to minus 5 plus minus root over b square will be 25, minus 4ac will become plus 4 divided by 2. Here also we will be getting one solution only. I cannot take the negative answer. So we are having the answers as e power x is equal to minus 3 plus root over 13 by 2 from this case, and the other case we are having answer as e power x is equal to minus 5 plus root over 29 by 2. So if we take log both sides with base e, we can get log base e minus 3 plus root over 13 by 2, and this is also x is equal to log base e minus 5 plus root over 29 by 2. So if you observe, root 13 will have values between 3 and 4. So let's suppose the value is 3.6 or any random value between 3 and 4 you think, then minus 3 plus that value will be less than 1, and less than 1 number divided by 2, again it will be less than 1 only. Let's suppose 0.8. So definitely when the log is having base e and the input to the log is a less than 1 number, this is going to be a negative. Same way root 29 is between 5 and 6. So when we add a number between 5 and 6 to minus 5, we'll be getting a number between 0 and 1, and that after dividing by 2 will still be a number less than 1, and between 0 and 1 we can say, and since base is e, it is also going to be negative. So answer here, two solutions and both are negative, because option D is also having two solutions, but there it is said that only one of them is negative. Question number 61 is the number of integral values of k for which one root of the equation lies in the interval 1 comma 2 and its other root lies in the interval 2 comma 3. So let's suppose we have 1, 2 and 3 over here, and since the coefficient of the quadratic is positive, graph is going to be a upward parabola, and the graph will be something like this: one root between 1 comma 2 and the other one between 2 comma 3. Okay, so based on this graph, if you observe, definitely at 1 the function will have positive value, at 2 the function will have negative value, and at 3 function will have positive value. So directly let us apply all these conditions. So f1 is going to be positive, which means 2 minus 8 plus k is going to be positive, which means k is going to be greater than 6. Same way f2 is going to be negative, so at f2 we'll be getting 8 minus 16 plus k less than 0, or I can say k is less than 8. At last f3 must be positive, so it will be 2 into 3 square, which is 18, minus 24 plus k, again that is going to be positive, so k value is going to be greater than 6 again. So finally if you club all this together, the answer says that k value is going to be greater than 6. At the same time the value should be less than 8. So the common portion is 6 to 8. So the number of integral values of k is going to be only one between 6 and 8, that is 7. K is equal to 7. That is the only possible option, because 6 and 8 were not included. There was no equal to sign in these inequalities. The correct answer is option C. Question number 62 says, let the complex number z be such that 2z minus 3i divided by 2z plus I is purely imaginary, and if x plus y square is equal to 0, then y power 4 plus y square minus y is equal to. So let's solve this. 2z minus 3i divided by 2z plus I can be written as 2 times of x plus iy minus 3i divided by 2 times of x plus iy plus I. Overall I can write this as 2x plus I taken common, 2y minus 3, and in the denominator it will be 2x plus, again I can take I common and write this as 2y plus 1. For making this purely imaginary, I need to put the real part equal to 0, and to get the real part I need to remove this iota term from the denominator. So I am multiplying by its conjugate, 2x minus I, 2y plus 1 in the numerator as well as denominator. Since we have to put the real part of this capital Z complex number, let's suppose, for making it purely imaginary. And we know that to get real part we need to multiply real into real, so 4x square, okay, and then imaginary terms into imaginary terms. So this I 2i minus 3 and minus I 2i plus 1, when they will multiply, it will be minus I square, which is plus basically, and 2y minus 3 into 2y plus 1, that is equal to 0. Okay, you can skip the remaining calculation because simple thing is real part has to be equal to 0. So we are only focusing about real part. Denominator anyhow will be a number, because if this is some complex number, then next one is its complex, and z into z bar is basically z modulus square, modulus of the complex number, and then square of that is just a number. So anyhow that will be equal to 0 when that particular number in the denominator will multiply with 0. So we are only solving real into real and imaginary into imaginary, that is equal to 0. So this is going to be 4x square plus 4y square, and then plus 2y, then minus 6y, and minus 3 equal to 0. From the given information where x plus y square equal to 0, I can write x is equal to minus y square. So x square will basically become y power 4. Okay, so here I can write 4 times of y power 4, right, and then we have 4 times of y square, and then minus 4y, and minus 3 is equal to 0. So 4 can be taken common, it is y power 4 plus y square minus y is equal to 3. So our answer, which is y power 4 plus y square minus y, is going to be 3 by 4, which is option D. Question number 63 is, let W1 be the point obtained by rotation of Z1 about origin through a right angle in anti-clockwise direction, and W2 is the point obtained by the rotation of Z2 about the origin through a right angle in the clockwise direction. Principal argument of W1 minus W2 is, so basically if you have a complex number Z1 and if you are rotating it through a right angle about origin in anti-clockwise direction, then for 90 degree it is basically e power I pi by 2, that is the multiplication factor, then you will get the W1. Okay, now e power I pi by 2 is basically given by the formula e power I theta cos theta plus I sin theta. If you put theta as pi by 2, we'll be getting e power I pi by 2 as I. So this is nothing but Z1 into I. So we'll be getting complex number 5i minus 4. After multiplying with I in Z1, we'll be getting 5i minus 4. W2 is the point obtained by rotation of Z2. So for W2, I have to write Z2 into e power I, but this time right angle in clockwise direction, so I have to put minus pi by 2. So e power I minus pi by 2 is basically minus I. So it means Z2 into minus I, this time we have to multiply. So it is minus 3i and plus 5, that is what we will be getting. Okay, minus 3i plus 5. So we know W1, we know W2, it is W1 minus W2, we can calculate as 8i minus 9, correct, which can be written as minus 9 plus 8i. So let's look at the quadrant it is belonging to. Minus 9 means on the left side, okay, and 8i means somewhere here. So the point is in the second quadrant, and if you observe this angle alpha, then that angle alpha is nothing but this is 9, this is basically 8. So we have tan alpha as 8 by 9. So alpha value is tan inverse 8 by 9. Now for principal argument of a complex number, we measure from this positive x-axis and we can go till pi. Okay, so if you see from anti-clockwise sense, I have to write the answer as pi minus alpha, which is pi minus tan inverse 8 by 9, which is option C. Number 64 is, let the determinant of a square matrix of order m be m minus n, where mn satisfy two equations in mn are given. If determinant of n times adjoint of m into a is given as 3 power a, 5 power b, 6 power c, then a plus b plus c is equal to. So first of all, let's solve these two equations and get the mn values in order to get the determinant of the matrix. So I'm multiplying this first equation by 4. It will be 16m plus 4n is equal to 88. And already I have the equation 17m plus 4n is equal to 93. Subtract this second equation from 17m plus 4n. We will be left with m is equal to 93 minus 88 as 5. So if m value is 5, we can put in this given equation 4 into 5 is 20 plus n is equal to 22. So n value is 2. So we know m, we know n. Determinant will be m minus n, that is 3. So we are sure of the determinant of this given square matrix. Now let's apply the given conditions here. The determinant of n times adjoint of ma. Let's put the values as well. M value was 5, so I can say it is adjoint of 5a. And then we have this entire determinant written over here. In place of n also, let's write the values. N value was 2 and order of the matrix was m. Okay, so basically we have 5 rows and 5 columns in this particular determinant. So when 2 will come out of that, we can write 2 power 5. Okay, and since we are having two adjoints over here, we can write determinant of 5a to the power n minus 1 whole square, where n minus 1 means 5 minus 1, that is 4 square. As I explained that since this 2 is inside the determinant and determinant will have 5 rows, so 2 will be taken common out of all the 5 rows, so this is 2 power 5, and the adjoint is occurring 2 times. So as per this formula, where we usually write determinant of a to the power n minus 1 whole square, we can write for 5a also. So that is the only difference in this question. Instead of determinant of a, we are having 5a here, and then order was 5, so 5 minus 1 whole square. So overall I can say it is 2 power 5 and 5a determinant to the power 16. Again 5 into matrix A. Matrix A is having order 5, so there will be 5 rows. So 5 will be taken out of this determinant from each of those 5 rows. So it will be 2 power 5 into 5 power 5, and 16 is also on the power, that will also be taken care here by putting 16 over that. And only thing left out is determinant A power 16. So 2 power 5 into 5 power 80, determinant was 3, so 3 power 16. But if you see right hand side, there is only 3, 5 and 6, there is no 2. So we can write this as 5 power 80, and to make 6 I require 5 threes. So I'm taking 5 threes apart from I mean out of these 16 threes available, so only left out will be 3 power 11. So 2 power 5 and 3 power 5 together I can write 6 power 5. So I'm left with 6 power 5, 5 power 80 and 3 power 11. So 3 power is a, so a value is 11. 5 power is b, then b value is 80, and 6 power is c, so c value is 5. So a plus b plus c is nothing but 96, which is option number A. Question number 65 is, let A is the given matrix and P is another matrix, then sum of prime factors of determinant of P inverse AP minus 2I is equal to. So I can write this given determinant P inverse A into P minus 2I is equal to determinant of P inverse into matrix A into matrix P minus, intentionally I can put instead of this identity matrix P inverse P. Okay, now how this substitution will help us, let us observe. I can take a P inverse common easily, so that will give us AP minus 2 times of P determinant. So P inverse can be taken outside of this determinant, because since the order of the matrices A and P are same, I can easily take out this P inverse determinant separately, and the remaining AP minus 2P, that determinant will still remain inside this. Again I can take P also as common, it will be A minus 2I that will be left out inside this determinant. So it is P inverse determinant into determinant of A minus 2I into determinant of P. So determinant of P inverse and determinant of P, they will cancel each other, because determinant of P inverse is nothing but 1 by determinant of P. Okay, so only thing left out is determinant of A minus 2I. So there is nothing to do with P matrix at all. We simply need to solve A minus 2I. So A minus 2I matrix, if I start to write here, it will be 2 minus 2 0, then this is 1 2 6, then again this is 0, then again this is 11, then 3 3, and this is also 0. So we can observe this is the A minus 2i matrix, so its determinant will be equal to, let's calculate the determinant. It will be minus 1, 0 minus 33, so minus 33, and then plus 2 will be left with 18 minus 0, so it is 18 only. So overall 36 plus 33, that will be 69. Factors of 69 is nothing but 3 and 23, so the sum will be equal to 26, which is option A. Question number 66 is, if A is a given matrix, B is another given matrix, then C is matrix A into matrix B into A transpose, and X is another matrix which is given by the multiplication of A transpose into C square into A, then determinant of X is equal to. Alright, so let's suppose if I'm taking determinant of matrix C, then it will be nothing but determinant of A B A transpose. Then I can write this as determinant of A into determinant of B into determinant of A transpose, since the order of both matrices A and B are same. Now A transpose determinant is also equal to determinant of A itself, so I can write determinant of A square into B. This is the value of determinant of C basically. Okay, first thing we have understood here. Now if I talk about X matrix, and if I take the determinant of X, again there also you can observe we'll be writing determinant of A transpose C square and A, which will give us determinant of A transpose, determinant of C square, and determinant of A. And therefore I can again say that it is determinant of A square into determinant of C square. So we have got the determinant of X. Now what we need to do, if you observe, in place of determinant of C, I can use this value from first equation out with determinant of A square, then this will be determinant of A power 4, and then determinant of B square as well. Alright, so this is going to be determinant of A power 6, determinant of B square. We can easily calculate determinant of A. It will be 2 minus minus plus 1, that is 3, and determinant of B is nothing but 1. So I can write here 3 power 6 and 1 power 2. So 3 into 3 into 3, that is 27, and again we will be having 27, that is nothing but 729. Alright, so option C is the correct answer. Question number 67 is, let the sum of the maximum and minimum values of the function 2x square minus 3x plus 8 divided by 2x square plus 3x plus 8 be m by n, where GCD of mn is equal to 1, basically greatest common divisor. Then m plus n is equal to, so this is quadratic by quadratic, and maximum and minimum tells us clearly that basically we need to find out the range of this quadratic by quadratic. So let's write y is equal to 2x square minus 3x plus 8 divided by 2x square plus 3x plus 8. Okay, and cross multiply, we'll be getting all type of terms, x square, x, and some constant terms. So I'm writing everything in a consolidated form after multiplying. So 2y minus 2 times of x square. Okay, so this term will multiply, and I'm also transferring the numerator to the left side after multiplication. So basically 2x square becomes minus 2x square, which is evident from here. Same way we'll be getting 3xy after multiplication, cross multiplying this one. So 3xy and plus 3x will be getting. So I can write, after taking x as common, I can write 3y plus 3. And then we have y into 8 also, so we have plus 8y minus 8 equal to 0. Now this is a quadratic in x, quadratic in x, and for real values of x, definitely d has to be greater than or equal to 0. D means discriminant. So discriminant of this particular quadratic is 3y plus 3 whole square minus 4 AC, which is 2y minus 2 into 8y minus 8, and that has to be greater than or equal to 0. I can take 3 common, whose square will be 9, and then y plus 1 whole square will be y square plus 2y plus 1, And then here also I can take 2 and 8 as common, so it will be 4 into 2 8, 8 into 8 64, and then y minus 1 and again y minus 1 greater than or equal to 0. So we are left with 9y square plus 18y plus 9 minus 64y square plus 128y and then minus 64 greater than or equal to 0. So if I transfer all these terms to right side, it will be 64 minus 9, 55y square, and then 128 plus 18 is 146. Right side it will become minus 146y, then 9 and 64. 9 minus 64. On right side it will become 64 minus 9, again that is 55. This is going to be less than or equal to 0. Now this can be factorized as 55y square minus 121y minus 25y plus 55 less than or equal to 0, or I can take 11y common, so it will be 5y minus 11y, and then I can take here 5 as common, so it will be minus 5 common, so we can get 5y, okay, minus 11 here also. In the first bracket basically it should not be 11y, here it is just 11, correct, because 11y into 5y will be getting 55y square. Next term is 121y, for that only 11 is required. So this entire term has to be less than or equal to 0. So which means I can say 5y minus 11 common and 11y minus 5 remaining term, that has to be less than or equal to 0. It means two answers are one is 11 by 5, another is 5 by 11. Okay, for negative answer we have to take the region between these two, because as per sign scheme it is plus minus plus. So if you see, the minimum value for y is 5 by 11 and maximum value is 11 by 5. So the sum of the maximum and minimum values, if you add up, that is 5 by 11 plus 11 by 5 is going to be 55 here, and this is going to be after taking LCM 25, and this is 121. So overall it is 146 by 55. This is as per the question m and n values, because the greatest common divisor of 146 and 55 is 1. So now we can add m plus n is equal to 146 plus 55, that is 201. So option D is correct. Question number 68 is, if z1 z2 are two distinct complex numbers such that modulus of z1 minus 2 z2 divided by 1 by 2 minus z1 into z2 conjugate is equal to 2, then four options are given. So we know that there is a property that z into z conjugate will give us the square of the modulus of that particular complex number. So here we have the modulus value, so let us first square it. So it will be z1 minus 2 z2 divided by 1 by 2 minus z1 z2 conjugate whole square, that is equal to 4, and then we can apply this property z into z conjugate. So it will become z1 minus 2 z2 divided by 1 by 2 minus z1 z2 bar, and then the conjugate of this will be z1 bar minus 2 z2 bar divided by 1 by 2 minus z1 bar into z2, that is equal to 4. Now let's multiply numerator as well as denominator. So we have z into z1 bar, that will give us modulus of z1 square. Then we have z1 into minus 2 z2 bar, so that is minus 2 z1 z2 bar. Then we have minus 2 z2 z1 bar, and then minus minus plus 4 z2 into z2 bar is modulus of square of modulus of z2, that is equal to 4 times. Let us multiply this denominator and send that side right side. So 1 by 2 1 by 2 1 by 4, then we have minus 1 by 2 z1 bar z2 bar, then minus 1 by 2 z1 z2 bar, and then minus minus plus z1 z1 bar z2 z2 bar. It is overall z1 and z2 modulus squares. All right, so if you observe, many things will get cancelled now. This 4 will multiply inside, and it will become minus 2 z1 bar z2. So this term will cancel this one. Then minus 2 z2 into z1 bar will get cancelled by the next term. when 4 will multiply with that. Okay, so we'll be left with modulus of z1 square, then plus 4 z2 modulus square, that is equal to 4 into 1 by 4, that is 1. And at last we have a term that is 4 times square of z1 and z2 modulus. So let's write on the top z1 modulus of z1 square minus 1 I can write, and then I can take 4 modulus of z2 square common. It will be 1 minus 4 times 4 already common, so it will be just z1 whole square, that is equal to 0. Now I can say z1 modulus square minus 1 can be taken as common, so we'll be left with 1, and then minus I can write here 4 square of modulus of z2, that is equal to 0. So there are two possibilities, either modulus of z1 is equal to 1, or modulus of z2 is basically half. Then only if you put this half value 1 by 2 whole square 1 by 4, 4 will get cancelled, 1 minus 1 will be getting 0. So these are the two possibilities. Mod of z1 equal to 1 represents circle of radius 1 with center 0 0, and mod of z2 equal to half represents the circle of radius half. So definitely z2 lies on circle of radius half. So correct answer is A. Question number 69 is the sum of all the solutions of the equation 8 power 2x minus 16 into 8 power x plus 48 equal to 0 is. So to solve this question, let's substitute 8 power x is equal to y. So this will become y square minus 16y plus 48 is equal to 0. So if you factorize this, you will be getting y square, then minus to get 48 I can write this as minus 12y and minus 4y plus 48 equal to 0. So one of the factors will be y minus 12, the other one will be y minus 4, that is equal to 0. So we are getting two answers, y is equal to 12 and y is equal to 4. So basically we are getting 8 power x as 12 and 8 power x as 4. So what will be the answer for x? It will be log base 8, okay, with 12 as the input, and here we will be getting log 4 with base 8. Okay, so the sum of solution will be basically log base 8 12 plus log base 8 4, and this will give us log m plus log n formula, log m into n. So with base 8 I can write this as 48, but again this 48 I can express like 8 into 6, and again I can apply log m into n formula, so it will become log 8 with same base and then log 6 with base 8. So overall it is 1 plus log 6 with base 8, that is option number C. Question number 70 is if alpha is not equal to A, beta is not equal to B, and gamma is not equal to C, then a determinant is given as 0, and we need to find the value of A by alpha minus A plus B by beta minus B plus gamma by gamma minus C. So let's apply the elementary operation R1 minus R2 in first row, as well as in R2 let's apply R2 minus R3. The idea behind this is to get some zeros first in the determinant. So R1 minus R2, it will be alpha minus A, beta minus B minus beta, and C minus C is 0. Again A minus A will be 0, this is beta minus B, and this is C minus gamma, and A B gamma as it is, since we have not applied any operation in R3, only in first two rows we have applied. Now simply let us expand this. We will be left with alpha minus A, then gamma times beta minus B, and then minus B times C minus gamma. Then next terms will be minus of B minus beta, and then 0 minus A times C minus gamma. Okay, and last term is anyway it is going to be 0, and since this determinant is also given as 0, we can put overall 0. So this is alpha minus A, okay, gamma into alpha minus A, beta minus B. Then next one will be, this is C minus gamma basically, so I can say minus B alpha minus A, C minus gamma. and then the last one will be minus of, you can observe this is 0 minus a c minus gamma, so minus minus it will become plus. And also be aware that this is the entire bracket where we need to stop, and after that this is the other bracket. Brackets are very necessary while calculating, otherwise you may end up multiplying wrong terms. So now this is going to be minus minus plus a times b minus beta and c minus gamma, that is equal to 0. So further, if you observe in the numerator part, you are having a by alpha minus a. So what we can do, we can divide with alpha minus a, beta minus b, and gamma minus c throughout. So the first term will be left with gamma by gamma minus c. Then next term, if you observe, it is minus b, but I will write it as plus b so that I can change this c minus gamma to gamma minus c. Okay, so alpha minus a and gamma minus c, they will be getting cancelled, and in the numerator, once they are cancelled, in the denominator basically beta minus b will be remaining, and in the last term I can say it is a times. When I will be dividing with this whole term, you can observe beta minus b can be written by taking minus common, and gamma minus c also can be written by taking minus common from these two terms. So minus minus, anyway it is coming out to be plus, and these two terms will get cancelled, and only term left will be alpha minus a. So after dividing everything, we are getting still 0. So option C is correct. Question number 71 is, suppose a matrix A satisfies a square minus 5a plus 7i is equal to 0 matrix. Then if a power 5 is equal to scalar a into matrix A plus b into identity matrix, then the value of 2a minus 3b must be. So in this question, if you observe, we can say a cube is equal to a into a square, and in place of a square we can use a square is equal to 5a minus 7i, correct? So this will be a into 5a minus 7i, and again we'll be getting 5 into a square minus 7 into a into identity matrix is basically a itself. And again we can repeat the same process. In place of a square we can again use 5a minus 7i and minus 7a, and this is going to give us 5 into 5 25a minus 7a at the end, that is 18a minus, and then this 5 into 7, so we are having minus 35i. So this is the value for a cube matrix. We have got a cube as 18a minus 35i. Same way, let us proceed for a power 4. I can say it is a square into a square, or basically I can say a into a cube also, that is also fine, right? So we can write here a into a cube. We have a cube just now calculated here, 18 times of a minus 35i. Again opening the brackets, this will be 18a square minus 35a. Still we have the a square value in form of a, so 18 times of 5a minus 7i minus 35a. So this is going to be 90a, and 90 minus 35, if you do, it will be 55a. So 55a minus 18 into 7, if you calculate, that will give us 126i. So this is the value for a power 4 matrix. Now we have to reach till a power 5. So one more calculation we have to do. A power 5 is nothing but a power 4 into a. So that will give us 55a square minus 126a. Okay. And again in place of a square we'll be writing 5a minus 7i, then minus 126a, and this is going to be 5 into 5 25, and 2 will be remaining, then again 25 and 2 275a, minus 7 into 5 is 35, so 5 is here and 3 will be remaining, so overall it will become 385 times of identity matrix minus 126a. So 275a minus 126a, that will be overall 149a minus 385i. This is our a power 5. So as per the given question, it is small a times capital A. So small a value is 149 and small b value is basically minus 385. So as per the question, the value of 2a minus 3b is basically 2 into 149 minus 3 into minus 385. Okay, so this is nothing but 298. Okay, and minus minus plus 3 into 5 15, 1 will be remaining, then 3 into 8 24 and 1 25, again 2 will be remaining, 3 into 3 9 and 2 11, so 1155 plus 298, that will give us 1453, and that's the correct answer for this question number 70. Question number 72 is, if z is a complex number such that mod of z minus 2 minus 2i is less than or equal to 1, then the maximum value of 2i z plus 4 is equal to. Now this can be written as z minus 2 plus 2i less than or equal to 1. Anything of this format, z minus z naught modulus is equal to r, basically represents a circle with center at z0 and radius as r. So if we observe, the center of this particular circle is 2 comma 2. Okay, so let me plot the given circle first. So this is a circle with center at 2 comma 2. All right, and since we have the inequality also less than or equal to, that suggests that it should be interior of this circle. Okay, the z point lies on the circle or it should be interior to the circle. Now the question is maximum value of 2iz plus 4. That part I can write 2i taken common, so it will be z minus 2i. Okay, because plus 4 is required, so 2i into 2i, that will give us 4i square. I square is minus 1, so we'll be getting 4 as it is. Since modulus is there, so I can take 2i modulus separately, and that modulus is basically just 2 itself. So actually they are asking the maximum value of this particular term, 2 times of z minus 2i. So 2 is fixed, only contribution is from this modulus, that when this modulus will be maximum. So again, mod of z minus 2i means 2i is a fixed point, it is somewhere here, it is 0 comma 2. Okay, 2i basically means 0 comma 2, it is a point on the imaginary axis. Now z is nothing but point lying on the circle or in the interior of the circle. All right, so when we have to calculate maximum distance from this point A, the maximum will occur only if you see through the center to the maximum extreme point, which is B here. So we need to calculate this AB distance. So already we know till center it is 2. Okay, and the radius of the circle was 1, so this distance is 1. So it's nothing but AB is equal to 3. Okay, and what is AB? AB is basically represented by this mod of z minus 2i. So I can say the overall answer is 2 into 3, and that is nothing but 6. This is the maximum value that it can take. Question number 73 is, the number of distinct real roots of the given equation is. So let us multiply this x power 5 inside this bracket. We will be getting x power 8 minus x power 7 minus x power 6. Okay, and then plus x power 5 and then 3x power 4, then minus 4x cube, then minus 2x square, then plus 4x minus 1 is equal to 0. Whenever you have higher power questions like x power 8 7 6 5 and all, then there are few specific values like 1 minus 1 2 minus 2 where you should check, because one of the roots are sometime mostly x equal to 1 and minus 1, and there we need to also sometimes be ready to apply increasing decreasing concepts. So let's figure out, if you put x equal to 1, then it will be 1 minus 1 minus 1 plus 1, then plus 3 minus 4 minus 2 plus 4 minus 1. So if you observe, 1 minus 1 cancelled, minus 1 plus 1 cancelled, minus 4 plus 4 cancelled, 3 minus 2 is 1, 1 minus 1 is 0. So I have just shown you that x equal to 1 is a root of this entire equation. So I can say x minus 1 is a factor also. So I can take x minus 1 in a bracket, and the remaining terms I can start writing. So we require x power 8 firstly, so I have to put here x power 7, then only x into x power 7 will get x power 8. So first term I have got, and minus 1 into x power 7 I will get the second term as well. Now next requirement is to make minus x power 6, so I need to write here minus x power 5, so that this x will multiply with that and we get this term as well. Plus along with that we are getting x power 5 also directly. Next term is 3x power 4, for that I need to write plus 3x cube, so that x will multiply with that term and we get this 3x power 4 as well. But when minus 1 will multiply with 3x cube, it will be just minus 3x cube. However, our requirement is what? Minus 4x cube. So for that I have to write here minus x square, so that when x multiplies with minus x square, I get that extra minus x cube as well. But minus 1 into minus x square, that is plus x square, but we want minus 2x square, which means I have to write minus 3x here, so that I get minus 3x square. Okay, and we get overall minus 2x square term. Again minus 1 into minus 3x, that is plus 3x, but our requirement is 4x, so for that I need to write here plus 1. Okay, so that x into 1, that extra x also comes here, and finally minus 1 into 1 is minus 1. So in a way we have avoided the long division process, and in a single line we are able to write down the x power 7 minus x power 5, all these quotient values basically. So again, if you check for this higher power question, if you put x equal to 1, it will satisfy one more time. You can check. Okay, so this is x minus 1 taken again as a factor. So again I can start writing x power 6. Okay, so x power 7 term I will be obtaining, and next one will be minus x power 6, but we don't want x power 6. For that I need to write plus x power 5, so that when x multiplies with x power 5, we get x power 6, which cancels the minus x power 6 value. Now through this I'm getting this minus x power 5 as well. So first two terms we have got. Now next is 3x cube. For that I need to write here 3x square, so I will get this 3x cube, as well as when minus 1 will multiply with 3x square, it will be minus 3x square, but I want minus x square, which means I have to make sure that plus 2x square is coming from somewhere. So for that I will write here 2x, so it will be plus 2x square, but minus 1 into 2x is minus 2x. So again we want minus 3x, not minus 2x, so another minus x is required. For that I will put minus 1 and it is done. So this is equal to 0, so we have x minus 1 whole square. Okay, now we have x power 6 equation. If you see, if you put x equal to minus 1, then this entire equation will be satisfied, because this is going to give us 1, but odd power of minus 1 is going to give minus 1. Then again this is 1, 3 into 1 3 only, then this is minus 2. Okay, and minus 2 minus 1, so this overall things will get cancelled. Okay, this is just to show you that x is equal to minus 1 satisfies this x power 6 equation. So let's say that x plus 1 is a factor of this. So for one more time I can say x plus 1 is a factor. So to get x power 6 I need to write here x power 5. So I will get x power 6 as well as x power 5 as well. Next term is 3x square. For that I need to write here 3x. So I will get 3x square also. But in order to get 2x, I need to write here minus 1. Okay, so overall we are getting the result in terms of x power 5 equation. Now you can see from here we got x is equal to 1 as the answer. From here we got x is equal to minus 1 as the answer. And we are left with an odd degree polynomial. And we know that odd degree polynomial has at least one root. And if you take this much portion and see its derivative, it is 5x power 4 plus 3, and it is going to be positive for all x belonging to R. Okay, so this much portion x power 5 plus 3x minus 1 is an increasing function base. This is an increasing function, definitely it is going to, if you check at 0, it will be having value as minus 1. Okay, at 1 this is going to give us 1 plus 3 minus 1, which is 4 minus 1 3. So at 1 we are getting a positive answer. So definitely between 0 and 1, it is going to cut the x-axis somewhere, and that is our second or basically third answer. So one answer is alpha, beta is -1, and then we have third root also here, gamma. So different roots we are getting. Okay, 1, -1, and something between 0 and 1. So number of distinct real roots for this question is 3. Question number 74 is, if the value of real number a, which is positive, for which the quadratic is given to be 0, and another quadratic is also there and having a common real root is 3 by root over 2 beta, then beta is equal to. So we have the quadratic equations as x square minus 5ax plus 1 is equal to 0, and then x square minus ax minus 5 is equal to 0. So let's subtract the equations. So this will be x square minus x square cancelled, and we are left with x common, a minus 5a, and then 5 plus 1, basically we are getting 6, that is equal to 0. So x value will be getting minus 6 by minus 4a, which is basically 3 by 2a. So this common root must satisfy the given quadratic equation. So let's put this x value in the first quadratic equation, so which is x square minus 5ax plus 1 equal to 0. So it will be 3 by 2a whole square minus 5a divided by minus 5a into 3 by 2a plus 1 is equal to 0. From here we can get the values of a. So this will be 9 divided by 4a square minus 15 by 2, okay, plus 1 equal to 0. So I can say 9 by 4a square is equal to 15 by 2 minus 1, which is 13 by 2. 2 and this 4, they will cancel each other and 2 will be left out. So I can say a square value is 9 by 26. So a value will be 3 by root over 26, where I can write 3 divided by root over 2 into 13. So if I compare with the given data, it is 3 by root over 2 beta. So definitely in place of beta we are having 13. Okay, so answer for this question is 13. If the system of Question number 75 is, if the system of equations has infinitely many solutions, then lambda minus u is equal to. So if you observe this system of linear equations, then this is of the type ax is equal to b. It is a non-homogeneous system of equations for which infinitely many solutions will exist when determinant of a, or the coefficient matrix, sometimes represented as capital D, that is also 0, and then other determinants like d1, d2, d3 all are 0. So let's take D3, because we want to find first of all out of lambda and mu one value at least, and then we can go for the other. So I'm taking D3 is equal to 0. So we will be getting 2, 3, 1 and 7, 2 mu. Then lambda 5, 32. This is basically determinant D. But for D3, I need to replace the third column with 3, 4, minus 1. Okay, so that we get mu value at least in the beginning, and then we can go for lambda value. So this will give us 2 times of minus 2 minus 4 mu, then minus 7 times of minus 3 minus 4, and then plus 3 3 mu minus 2 equal to 0. So this is minus 4 minus 8 mu, then plus 21 plus 28 plus 9 mu minus 6 equal to 0. 9 mu minus 8 mu is simply mu. Then we have 21 and 28, that is basically 49. 49 minus 4 is 45. 45 minus 6 is 39. So mu value is coming out to be 39 on the left side. After going to right side, it will be minus 39. Now once we know the mu value, we can actually put determinant D also equal to 0 by writing 3, 2, 3, 1, then 7, 2 mu. Mu is basically now minus 39, and then lambda 532. So only unknown is lambda here. So we can start writing 2 times of 64 minus minus plus, and this will be 195. Okay, then we have minus 7 times 96 minus 5, and then finally plus lambda we'll be having minus of 39 into 3 is 117, and then minus 2, that is equal to 0. So 195 plus 64 is basically 259. Okay, 259 into 2 is basically 518. 96 minus 5 is 91. 91 into 7 is basically 637. Okay, and then here we are having minus 119 lambda, that is equal to 0. So 119 lambda is equal to minus 119. So lambda value is coming out to be minus 1. So the right answer for this question is basically lambda minus mu is minus 1 minus of mu, which is minus 39. So it's 39 minus 1, which is 38. Question number 51 here is, if alpha comma a are roots of the equation x square minus 2x plus 3 equal to 0, then the value of